Galactokinase deficiency is an inherited disease that leads to a buildup of galactitol in the blood. In this video, we'll show you a visual mnemonic with high-yield information to make it easy to recall on test day. Shoot for the stars! See that galactic kite? This galactic kite, successfully launched by our astronauts, should help you remember galactokinase deficiency. Get it? Since galactic sounds like galacto and kite sounds like kinase. Fun fact, these galactic kites or solar sails are actually a thing. Apparently, they can move things in space and save fuel. Just remember this galactic kite to anchor you to this scene on galactokinase deficiency. So, how do we know we're in space? Well, take a look at that rover on that planet. Poor little guy has been left all alone on the planet while the astronauts celebrate. How inconsiderate. By the way, this rover is a type of small auto, right? And small autos are Pixarize's recurring symbol for autosomal recessive inheritance. Therefore, this small recessive rover should remind you that galactokinase deficiency is inherited in an autosomal recessive pattern. We now know that galactokinase is deficient, but what does galactokinase do anyways? Well, recall how kinases work by adding phosphate groups to things. So galactokinase functions by, adding a phosphate group to galactose. Let's take a moment to review why this is important in the context of galactose metabolism. The first step of the metabolism of galactose is the addition of a phosphate group to produce galactose 1-phosphate. This step effectively traps galactose as galactose 1-phosphate inside the cell, before a second reaction converts galactose 1-phosphate into glucose 1-phosphate. But in the context of galactokinase deficiency, we can't trap galactokinase inside the cell. So where does all this extra galactose go? Well, some of it just builds up in the bloodstream, but importantly, an alternative reaction is catalyzed by aldose reductase to produce galactitol from galactose. Normally, galactokinase dominates, so very little galactitol is produced. However, without galactokinase, aldose reductase takes over, and much more galactitol is made. This has clinical ramifications and helps to explain some of the clinical features of this disease. Before we move on, I want to say that galactokinase deficiency is quite mild. This is because galactose is never trapped inside the cell. In contrast, classic galactosemia is another disorder caused by defects in the second reaction, turning galactose 1-phosphate to glucose 1-phosphate. In that disease, galactose 1-phosphate accumulates inside cells to toxic levels, leading to severe disease that is often fatal. You can learn more by watching our scene on galactosemia. But for now, just remember that galactokinase deficiency is far more benign than its counterpart, classic galactosemia. All right, so what are the clinical features of galactokinase deficiency anyways? Well, take a look at how our astronauts are celebrating the galactic kite launch. With galactic ice cream. Yep, it's galactic floating high in the air. We are on a space station after all. Anyways, this high-flying ice cream should remind you of elevated galactose. You know, since ice cream is sweet like sugar, so galactic sugar should get you to galactose. Elevated galactose levels are seen in the blood and urine since cells can't trap or metabolize any of it. This should be pretty easy to remember, right? One more note. Exam writers can tell you that there is galactose in the urine as the presence of a reducing substance in the urine, but with a negative urine dipstick. Let me unpack this. Sugars are reducing substances, and galactose is a reducing sugar. The urine dipstick, however, only tests for glucose. So a reducing substance in the urine with a negative urine dipstick should point you to another sugar in the urine, like galactose or fructose. Just thought you should know. The astronauts are really ready to party. Not just ice cream, but champagne. This bottle of champagne will help you remember the buildup of galactitol. You know, since galactitol is an alcohol just like champagne. And what do you call space alcohol or galactic alcohol? Galactitol, of course. As we've previously discussed, extra galactose not metabolized via galactokinase is instead shunted down an alternative pathway, producing galactitol. The astronauts have plenty of galactic alcohol to celebrate, which you can remember as the accumulation of galactitol. Got that? Let's move on. Now, when you pop a champagne bottle, accidents tend to happen, even in space. Look at where all the galactic alcohol went. Yep, right onto the helmet. Man, now I can't see anything out of this helmet. You might even say that this champagne has made the lens of this helmet cloudy. And you know what a cloudy lens reminds me of? Yep, cataracts. The accumulation of galactitol is relevant because it happens in the lens of the eye. This can present in newborns as infantile cataracts. It can also present as babies failing to track objects or not developing a social smile. You know, because usually seeing smiles or following objects requires you to be able to see. Since galactokinase deficiency is relatively mild, infantile cataracts will really be just about the most important symptom. Alrighty, so we're done with galactokinase deficiency. While our astronauts celebrate, let's quickly recap. Galactokinase deficiency is an autosomal recessive disease that is characterized by a lack of galactokinase. Without galactokinase, excess galactose accumulates, and aldose reductase converts some of this galactose into galactitol. Elevated galactose levels are seen in the blood and urine, and buildup of galactitol in the lens of the eye can cause infantile cataracts. Thanks for watching. Let's put on our space helmets and go join the party, shall we?